Okay, here we go with the first question. Write down the range of f. So if we look at this, we've got 9 minus x squared, and x squared can only be positive. So 9 minus x squared, this will always be negative. So it's always going to be 9 take away a number. So that means the maximum value we can have is 9. And the minimum value is minus infinity. Okay, so that's what's going to help us do the range. So the range of f of x is less than or equal to 9. Now, part B, we want fg of 1.5. So first we have to do g of 1.5. So that is 3 over 2 times 1.5 plus 1. So we get 3 over, now 2 times 1.5 is obviously 3, plus 1 is 4. So g of 1.5 is 3/4. Now we need to substitute that into f. So we can put in 3/4 as a fraction, or we could put in 0.75. But this is 9 minus 3/4 squared. 9 minus 9 over 16. And that is 8 and 7 over 16. Or 8.4375 if you did it in decimals. Now, part C is g to the minus 1. That's what we want to find. So first of all, let's start with g of x, but we're going to call it y. So y equals 3 over 2x plus 1. Now we're going to rearrange so that x equals, so we're making x the subject. So multiply up by this bottom bracket and expand. So that would be like 2xy plus y equals 3. 2xy equals 3 minus y. And divide by the 2y, so we get x equals 3 minus y over 2y. So then this becomes, so it's g minus 1 of x, and it becomes 3 minus x over 2x. Now, as for the domain, we got x as an element of, now it can't be 0, because obviously 2 times 0 would give me 0 on the bottom. So it's got to be, and this is obviously greater than or equal to 0 as standard, so it's got to be, greater than 0, can no longer be equal to it. So you can use this terminology, so it would be like a curved bracket for the 0. And then, if you remember now, that was the original domain, which means that this is now the range. So as a range, this has got to be greater than or equal to 0. So if you look here, if I've got 3, x is 3, it would be 0. And then above 3, like 3.1 or whatever, 4, then this becomes a negative value, which is not acceptable because the range is greater than or equal to 0. So this is everything up to and including 3. So you can use that terminology, or you could use that it is less than or equal to 3 and greater than 0. It's up to you. Okay? And it's the same over on part A. You could use this kind of terminology here when you have, and I'll pop it over in red over here now, but you've got minus infinity to 9. And 9 is the equals part, so it's like up to 9 and including 9, so it's a square bracket. and obviously a curved bracket for it doesn't equal. Obviously we can't get to minus infinity. In this case it doesn't equal 0, but it's everything up to it. Okay, and that is question 1. Okay, question 2. There's a few ways to do these types of questions, but where I like to start is with the r cos. So this r cos x minus a. So I like to expand that. Yeah, so I mean I can do this even a few different ways, but let's set it up like this. This is going to be equal to the cos x plus 2 sine x. And our cos, if you think of the cos, so that's when you've got cos, it's going to be cos x cos a plus sine x sine a, yeah, with the opposite sign there. So and obviously r times that, so r cos x cos a plus r sine x sine a, and that is equal to cos x plus 2 sine x. Now I'll use my highlighter here. If we look at the first section, there's cos x, there's cos x, and then we have this r cos a. So r cos a. Now that's going to be equal to, in this case, 1, because that's just 1 cos x. So we can say now that r cos a equals 1. And then looking at the second part with the sine, if we take the sine x's out to it, then this r sine a must be equal to the 2 there. So we got r sine a equals 2. And I find if you set it out this way, you'll never make any mistakes with these. Okay, you won't get them wrong. I've seen some people sometimes get them the wrong way around, and this just enables you to avoid that mistake. Now it's quite straightforward. If we do the sine one here divided by the cos one, we would get r sine a over r cos a equals 2 over 1. Now the r's are going to obviously cancel that. Sine over cos is tan, so we get tan a equals 2. Now looking here, this should be in radians, so set our calculators to radian mode, and we get that a equals 1.107 to 3 decimal places there. Now, yeah, didn't even notice that it does say 3 decimal places. I was just about to check, but I would still store that in my calculator. So right now I've stored that value as a, so I've just stored the full value as a. Now for the next bit, I could use this a, this angle, with one of these two equations to find r, or I can use Pythagoras. So in this case, I'm going to use the Pythagoras. So this is r squared equals 1 squared plus 2 squared. So r equals square root of 5 there. So now we can state that cos, give me a second there, cos x plus 2 sine x is equivalent to root 5 cos x minus 1.107. Okay, and you should do that to finish off with. It's good practice. Now, looking at part B, it says using your answer to part A, write down the exact maximum value of g of x. Well, the maximum value of f of x is going to be looking at this. Is obviously when cos is 1 gives me the maximum, so root 5 just for f of x. Now this is going to be f of 2x. Now that obviously stretches it out, but of course in this case we'd actually want it at minus root 5, wouldn't we? So, you know, just think of your graph. It's cos, isn't it? So it's going to look like this kind of thing. Normally, you know, that's at... Actually, I don't know why I bothered drawing that, but anyway. When it's minus 1 is what we want. So it's going to be g of x is equal to 3 minus 7 root 5, and it's not minus, it's going to be plus. So that would be my maximum value there, and it would happen when obviously that cos is going to give me minus 1. The next part is to say when this will happen. So find the smallest positive value of x for which this maximum value occurs. So as we said earlier, we're going to need the value when the f of x is minus 1, don't we? And this happens at pi for cos, doesn't it? Or 180 degrees. So for the second part, what we've got to think about is we've got to think about this. If we think about our angle, so at the moment we've got root 5 cos, and it's x minus 1.107, isn't it? And what we're doing is, well, we're saying, well, currently this is, if you think of it like cos, isn't it? We want 2x, so substituting in 2x instead of x, we'll give it this, and then we want this to equal minus 1. Because when we put this as minus 1 into here, that's what gives us the plus there. So this means that 2x minus 1.107 must be equal to pi, because cos equals minus 1 at 180 degrees, or pi. Then, you know, obviously other values, but we just want this the smallest possible positive value, don't we? And here now it's just a matter of rearranging. So pi plus 1.107, and then x equals pi plus 1.107 over 2, and popping that just into my calculator. Obviously I use the full value for the 1.107, and this will give me 2.12 to the 2 decimal places, and of course that's positive. If you wanted to think about, well, where else does this be minus 1? Well, if I try to look for an earlier one, the next possible value I'd need would be at minus pi. And if I put minus pi plus this, it's going to give me a negative number, isn't it? Because minus pi is 3 point something. So if you're adding 1 point something, it's still going to stay as a negative. So that's how you know that you wouldn't use the negative pi. And of course you wouldn't use additional further along, because that wouldn't be the smallest positive. So that's how I know that this is the correct answer in this case. But in any one of these types of cases, you will have to consider a couple of different options, because it is a repeated pattern, isn't it? The sine or cos graph. Okay, but hopefully this has helped you to understand this in this question. Okay, in this question here we're dealing with kind of logs, isn't it? And when we convert them so that we get nice straight line graphs to be able to predict things and so on with a pattern. Now what we need to do here is effectively find y equals mx plus c. So I've got two coordinates here, So I'm going to do it the way I like to do it. It's just I don't like to find it necessarily in one go. Find the gradient first, and then I'll find the actual equation. So anyone take away anyone. Let's start with this first one here. So we'll start with the 0 and the 1.5. So it's difference in y's. So 1.5 minus 0 over 0 minus 4.8. And this gives me the value 5 over 16. Then I want to think about my y minus y1 equals mx minus x1. So that's obviously y minus, and I'll use the same first coordinate, the 0, 1.5. So y minus 1.5 equals, I don't even really need to do it this way, did I? 5 over 16 brackets x minus 0. Y equals 5 16th x plus 1.5. I just realized that 1.5 is the plus c, so I didn't even need to do this. So I'll just rub that out because that was a bit of a waste of time there. So that's why I'm looking at the equation, except for the fact that it's not y. It's log to the base 10. So it's log y to the base 10. So what I actually need to do is change this y into log y to the base 10. And then this is my equation for L. Okay, and that would be part A there. Now, for the second part, we've got to put it into its index form, its power form. So this is going to become y 10 to the 5 over 16x plus 1.5. Okay, that means it's y to the 10 5 16th x times 10 to the 1.5. Now, all the values we have to give the three significant figures. So 10 to the power 1.5 is 31.6. That is our value of k. Now, initially I want to be writing times 10 to the 5 over 16th x. But obviously when we look back in our original here, what we want to find, the form, b is to the power x. So we need to do something here so we've only got an x as our power. Now what I can do is, and I'll do this just on the side here, when I have something, raised to a power and then to another power like so, this is when I multiply the two of them, don't I? So I can use this, so this now would be my value of b. And that means that I've got 31.6 times, and then this is 2 point, and what was it, three significant figures, wasn't it? 2.05 to the power x. So k is 31.6 and b is 2.05. Hopefully that made some sense. Now there's a couple of ways we can do this. We could use a long division, but I prefer setting it out and doing it by inspection. So if I write this out, and this is what I end up with. So there's my f of x here, and then this is obviously the format for the f of x that we want on this side. So if you think about it, if I multiply by the x plus 3 squared, the bit that's on the bottom on the left hand side of my equivalent sign, so I get this, and then on the right I get ax squared plus bx plus c times x plus 3 squared plus d. Because obviously when I multiply the d over x plus 3 squared times by this, that would just give me d. So that's what I've got plus the remainder there. Now what I can do is I can compare. coefficients. So I'm going to start off by comparing x to the power 4. Now for this, I want to be thinking about what this is expanded. So just for you guys, I'll put it above. So it's x squared plus 6x plus 9. But generally I do this in my head for that. But anyway, so if I think about the x to the power 4, the coefficient of it on this side, on the left hand side, is 2. And then the coefficient for that on the right. So the only way to get x to the power 4 is this x squared times this x squared. Yeah, so that would be a x to the power 4. So the coefficient is a. So right off the bat, I've got that a equals 2. Next one I'm going to look at is a cubed. So on the left hand side, I can see that a cubed is 15. But when I come to the right hand side, there's a couple of different ways I can make a cubed. So I can have this ax squared times 6x. So that would be 6ax cubed. But also I could have had bx times x squared, which would be bx cubed. And of course I'm just writing down the coefficients. Yeah, so that's what I've got there. Now we know what a is. It's 2. This means that b here is 3. Yeah, so now we've got 2 values. And at this point, on a normal one, I'd go to the constant. Yeah, but I've got 2 constants here. I'll end up with the c's and the d. So I'll leave the constant until the end. So this one now, I want to look at either the x or the x squared. I'll take the x squared, 35 on the left. Now, on the right, there's a few different ways. So ax squared times the 9. So that would be 9ax squared, so 9a. Then I've got the bx times the 6x. That would be 6bx squared, so plus 6b. And then I've got the c times x squared. So that would just be cx squared or plus c. And of course, I've already worked out what a and b is. So 9 times 2 is 18, plus 6 times 3 is also 18. So we've got 35 equals 36 plus c, so c is -1. I've now got 3 out of the 4 constants, or 4 values that I need. Now I need this d, so I'm going to go with the constants here for the last bit. So constants on the left is -4. So I'll pop that, -4. And then when I look on the right, the only way to get the constants is c times 9. 9c plus d. So that's -4 equals, now c is -1, so this is -9 plus d. I'm adding the 9 to the left hand side, so that's going to give me 5. So 5 equals d, or d equals 5. Let me like so. Okay, so now I've got all 4 of my values, and what I should always do then is put it back into the original format it wants it in. So it's a is 2, so it's 2x squared, b is 3 plus 3x, c is -1, d is 5, so plus 5 over x plus 3 squared. Now, part B wants me to integrate f of x. So that is simply integrating this. So add 1 to the power, divide by the new power. 3x, add 1 to the power, divide by the new power. And then when we get to this one here, I'll just pop it again down in red. This would have been 5x plus 3 to the minus 2. So add 1 to that power would be minus 1. Divide by that power, so dividing by minus 1. And that would give me minus 5 over x plus 3. Obviously when you divide by minus 1, it goes from a plus to a minus there. And there's nothing really to simplify, so that is the final answer for part B. Oh, there is one more bit, plus C. There we are, don't forget that plus C there, because we've got no limits, so you need to make sure you have that. Okay, here we have, well, some bit of trig here, so let's go ahead and work this out. I'm going to start with the left hand side. So typically I'd write that part of the question out. So there you have my identity, and I would start with the, well, whichever side you want to start with. I'm going to start with the left hand side. Now obviously you wouldn't have to write the actual question out because it is given to you. So I'm going to start off with this, and it's not always obvious where you start, but we've got things in terms of cot there and cosec. Cosec is obviously 1 over sine, cot is the 1 over tan, and we've also got cot there. But I think I'm going to start off by the fact that these two are singular. It's like one thing together. I need to really make these two just like one bracket. So I think there's a couple of ways I could do it. I could break this down in terms of sine and cos, which is my first instincts. However, I'm going to start off just by making this in terms of tan and see where I go. So that's what I've got there. Now, if I do this, it's looking like I'm going to end up with a tan to the power 4 on the top, which I think I might be able to come from, but I don't know if it's the best way to go. So let's go back to my first instincts, which was to make this in terms of sine and cos. Sine squared over cos squared. Now, when I put these together, looking at the top, so we would need to multiply by another cos. I'm still going to have powers of 4. Like so, minus sine. Let me just sort out this bottom. Be sine squared x cos squared x. Sine to the 4x. Sine squared cos squared, both x's in there. And then let's put them as one bracket, or one fraction I should say. I've got this over sine squared cos squared. So I'm just going to put that all over the one thing. So that's a nice start. Now, this sine cos is hopefully what's going to get me to my 2x, because I know that sine 2x is 2 sine x cos x. So this means that if I rub out the 2 and put a half there, then this is going to give me this, isn't it? So that's the first kind of nice step. That's going to give me my cosec 2x, and that dividing by half will bring a 2 to the top. Actually, bring a 4 to the top, won't it? Because this is squared. So that is the cosec and the 4 all sorted. Next, I need to deal with this. So cos to the power 4x minus sine to the power 4x is the difference of two squares. So this is, let's see, cos squared x minus sine squared x, and then cos squared x plus sine squared x. Works with all kind of even powers, but look, you know, cos times cos, cos to the power 4, and then these will cancel. Yeah, cos sine squared and sine cos squared, positive and negative, and then that's your sine to the minus 4. So that's all nice. Then on the bottom I've got the half sine 2x, and that is squared, isn't it? Okay, so this point I'm just gonna rub this little bit out over here, so I've got plenty of room to carry on with. And this is just 1, isn't it? Sine squared plus cos squared equals 1. So that is a little bit more done now. So I'm just going to rewrite it so that you can see a little bit better. So this is what I'm down to now. 1 over 4, and that's sine squared 2x. So here we are making some great progress. Now it's just a matter of dealing with this. Now, if you think back to cos 2x, cos 2x could be written as cos squared x minus sine squared x. There's obviously a couple of versions of this, as in 2 cos squared x minus 1 and 1 minus 2 sine squared x. But that's the standard first version that you learn, and that is what we've got there. So now we can replace that top with a cos 2x. So let's go with that. So now I've got cos 2x, and then on the bottom I've got 1/4. Let's put the quarter onto the top, so before sine squared 2x. Next I need to think about, right, and I'm going to need a sine on the bottom to give me the cosec, and we got cot, which is 1 over tan, so it's cos over sine. And we've got a sine squared, so we can split that up. So effectively we're looking at, and I'll take the extra step so you can see, so over sine 2x, like that. So it's like cos over sine gives me the cot, and 1 over the sine gives me the cosec. So here now we have 4 cot 2x cosec 2x, and that equals the right hand side. Whew, quite a bit of work there for 4 marks, I feel, but it's just manipulation, and I probably would have got there if I just stuck with tan, but it was definitely easier, I think, switching to the sine and the cos. And obviously the clue with the 2x, you knew you had to use the double angle formulas. Okay, so just making sure you're pretty aware of those. Now with part B, we need to solve it. So we've got this equals this. Now 4 cot 2 theta cosec 2 theta is what we've got up here, isn't it? So it looks like we can do a bit of replacement there, and it looks like we can replace it with that. So if I start with what's in the question, just for you guys, and kind of for me, I do like to rewrite some things out, certainly when I'm working them out. And then this left hand side I can replace with cot squared theta minus tan squared theta equals 2 tan squared theta. And that is then 3 tan squared theta equals cot squared theta. Now cot squared is 1 over tan squared theta. and multiplying up by that, I'd have 1 equals 3 tan to the power of 4 theta, or tan to the power of 4 theta equals 1 over 3. Tan theta would be plus or minus the 4th root of 1/3, and then I can go ahead and find that theta. Now it's in radians, so make sure you use radians in your calculator. We're going to do the 2 decimal places, so at least use 3 decimal places in any of your working out. That way then 2 decimal places will be accurate. And we have 0.6497. I do a couple of decimal places extra there for dp, just while I'm working things out. And in my calculator, I've just stored that as b. I'll just note it on there to remind me that that's what I've done. Now what I need to do is think about what's happening. I need all the possible answers. So I'm thinking of my cost. This is 0.6, well, basically 0.65 there. And we're looking at when tan is both positive and negative. Yeah, positive and negative. We've got 2 solutions. So we're actually looking in all 4 quadrants. However, we are only going as far as pi by 2 and minus pi by 2. So in fact, we're only looking here and here. Now that makes our lives way easier. So that means that theta is equal to 0.65 and negative 0.65. Just 2 simple answers. Remember that 0 to there is only 1 angle, and then 0 going in the negative direction to here, there's only the 1 angle. And it's just theta, so it's nice and easy. Weirdly enough, it's worth 5 marks, but I'd say that part B was way easier than part A in this case. Now, if you've stuck with me so far and you are finding some use in this video, don't forget to hit that like button, and if you haven't done so already, hit the subscribe. Okay, right, let's look at the next question. Okay, this is an interesting one. I've just put the equation there, ready. Now, A is just a positive constant. Okay, that's quite important, just remember that's positive. When I look inside my modular sign here, I've got a 3x. A is just a constant, remember that, so that number 5 times A is just 5 times a number, it's just a number. So this is important, 3x here. So this 3x is positive. Okay, so it means that we're looking at, when we look either side of this, when this is all positive, we're looking at this side. When this is like negative, we'll be looking at that side. So that's quite important as we go through this. And at this point where it changes would be when this bracket is equal to 0. So it's just going to be that minus 2a there. Now we have to find the coordinates of P, Q, and R, and S. Okay, so that's obviously this one. So we don't know the X value, but we know that that Y value is that 2a straight away. Yeah, and this is obviously when Y equals 0, and then we're solving that to get these 2 values. And then P is just going to be, well, when X equals 0. So we'll start with finding P, and that's going to come with X equals 0. So if I substitute that in, we'll be looking at Y equals minus 5a in the modulus sign, minus 2a. So that's actually 5a minus 2a because of the modulus, and that's 3a. So P is 0, 3a. And there's my first value. Now, my second set of values is going to be when y equals 0. So here now I've got 3x minus 5a minus 2a equals 0. And I've got two options. Yeah, option 1 is the positive version of this modulus sign. And option 2 is the negative version of this modulus sign. So this means I've got 3x minus 5a equals minus 2a equals 0. 3x equals, so we've got minus 5 minus 2 is minus 7, so that'll be 7a on the other side. X equals 7a over 3. So that is my first value of x. When I look at the other one, I'd have minus 3x plus 5a minus 2a equals 0. 3x over the other side, and I got 5a minus 2a is 3a, so x equals a. And then looking at these two, 7 over 3 is greater than 1, isn't it? So that's going to be r, and the a will be, and this one will be for q. So q is a 0, and r is 7 over 3 a 0. Then for the final one, we can work this out. It's going to be between these two values of r and q, between 1 and 7 over 3. So the midpoint would be 1 plus 7 over 3. That's just in terms of a, divided by 2. So 5 over 3a. So point S is 5 over 3a, comma, minus 2a. Now, alternatively, the way we could find it, and I put it in red over here, is we make the inside the modulus 0, because that's what's going to give me the smallest value. This is always positive. So to get this minimum value, it would be when this is 0. So this would mean we'd have 3x minus 5a equals 0, which straight away means that y equals minus 2a. And then 3x equals 5a, x equals 5 over 3a. So you can see that we can get the answer in two different ways. So we're going to solve this equation, okay, and it's worth noting or worth understanding what it's going to look like. So y equals x minus 2a. Yeah, so it can't have any negative value, so it won't drop below this axis. When x here equals 2a, x minus 2a equals 0, so x equals 2a. That's where it's going to touch the axis. So you know that 7 over 3 is bigger than 2. Yeah, so we know that this is, for example, going to touch somewhere between q and r. Yeah, that's what's going to happen. And then when it hits the y-axis, that's when x is 0. So it's going to hit at minus 2, which is made positive, so it's going to hit at 2a. So we know it's going to look something like that. Yeah, so it's a rough sketch, and what you can see from this sketch is that we'll have 2 points of intersection. Okay, it's quite important that we know we've got 2 points of intersection, and we know that the gradient is not as great because it's a single x, not a 2x like this, or 3x like these. So we do know it's not going to go up. You know, if this was like a 3x or a 4x, then this would be different, because we know when it hits this line, it wouldn't cross again this part. So what we've got to do here now is solve for two different ones. So we're going to get 3x minus 5a minus 2a equals, and we're looking at x minus 2a. So if I think of what's happening here, this is when both of these are positive, yeah? They're both, it wouldn't matter if I take the inequality away. This graph would still look like that without this modulus sign, and this graph would still look like this without its modulus sign. So now I can solve these. So 3x minus 7a equals x minus 2a. So that is 2x on the left and 5a on the right. So that is x equals 5 over 2a. Okay, so that is, and we're only solving for x, so that's all we need to worry about there. Now, when we look at the second one, what's happening with the second one? Well, the second one is happening with the changed graph. So we know this should be minus, and this also has the changed graph. So we're actually looking at minus 3x minus 5a minus 2a equals minus x minus 2a. So minus 3x plus 5a minus 2a equals minus x plus 2a. So if I add 3x to the other side, I'd get 2x. And then if I minus 2a, I'm going to only get a. Can you see? So 3x take to the other side will give me 2x. This is 5 take away 2, which is 3. And then we minus in 2, which is just 1. So x equals half a. And that is my second answer. Obviously, having the sketch of the graph does make things easier, yeah? So you can see exactly what's happening. Okay, let's look at the next question. Okay, so here we've got this equation. It's in terms of x, but we won't worry about that. And we've got to differentiate it. So if we differentiate it, so it's going to be dx by dy. And when I think about differentiating tan, I get this. This is in your formula booklet, so you don't need to worry too much about it. But tan differentiates to sec squared. So this will go to 3 sec squared, isn't it? Sec squared y minus pi over 6. And when I look back here, if it was multiplied by anything in there, I'd just have to do it by the outside, but I don't have it. It's not 3 times anything or 2 times anything, the brackets. So that's what we've got. Now we need to really put it in terms of dy by dx. So dy by dx would be 1 over 3 sec squared y minus pi by 6. Now for the next bit, so I know it looks a little bit confusing, but that's x squared plus b. Now this is x. Okay, so what we're really looking at is that x squared we want would be 9 tan squared y minus pi by 6. That's what we need to do. Now, when I look at thinking about this, so sine squared plus cos squared equals 1. If I divide through by cos, yeah, by cos squared I should say, I get tan squared x plus 1 equals sec squared x. So that means that this can be replaced by 1 over 3 brackets tan squared y minus pi by 6 plus 1 close brackets. Okay, and that is of course now quite important. So expanding my brackets, I get 1 over 3 tan squared my angle plus 3. Now for me to change it to an x squared I need 9, so I need to times by 3. So I need to times top and bottom by 3. So multiplying by 3 over 3. So that would give me 3 over 9 tan squared my angle plus 9, which is 3 over x squared plus 9. And that is my dy by dx. So you've got your a is 3 and your b is 9. So we've got the point P with y coordinate a third pi. Given that the tangent to C, so that would be this dy by dx, at P crosses the x-axis at the point Q, find in the simplest forms the exact value of Q. So first there's P with the y coordinate. So I now, to use this, I need the x coordinate, don't I? So we know that x equals 3 tan, and then y is pi by 3 minus pi by 6, isn't it? Now this is obviously in radians. So it's 3 tan pi by 6, and in my calculator it gives me that x is root 3. Okay, so dy by dx is 3 over root 3 squared plus 9. So 3 over 3 plus 9 is 12, or 1 over 4. So that is my gradient. Now I have the gradient, so m equals 1/4, and I have a coordinates for P, don't I? Which is pi by 3. No, I shouldn't put it there, should it? That's the pi by 3 is the y value. It is root 3 comma pi by 3. That's my coordinates. So what I'm going to do now is I'm going to find the equation of this line, and then when it hits the y-axis, isn't it? Oh no, it crosses the x-axis. So this is when y equals 0 then. So let's do this. So y minus pi by 3 equals 1/4 x minus root 3. 4y minus 4 pi by 3 equals x minus root 3. That's just me getting rid of a bit of the fractions. Still got one though, haven't I? So I've got x minus 4y plus 4 pi by 3 plus root 3 is my constant there. Okay, you could have just left it in terms of y equals mx plus c, so that would have been, I'll pop this in red, y equals 1/4 x minus root 3 over 4 plus pi over 3, and that would be like your constant there, so I'll leave that out of the brackets, but yeah. And there we have it. Apologies, I just changed this back to the minus because minus there and I wrote plus just now. So the point Q, y equals 0. That's what we know at point Q, don't we? It's where it hits the x-axis. So now we've got, so at Q, we've got the x, the y would disappear, plus 4 pi by 3 minus root 3, and we want just x, so x equals root 3 minus 4 pi by 3, and it is the exact answer, so that is it. Strange question. I think, but yeah, not too difficult. Just following, it's weird numbers to deal with, isn't it? But you just follow your instincts. Interesting. I would think there's lots of different ways to do this one. With a cos and a sine, one could say you could convert into just like an r cos something or an r sine something. But let's just go with an integration. So I'm going to call that I equals. So then I've got I equals there. And I'm going to expand this. So it's going to be 4 cos squared x minus 4 sine x cos x. So that's obviously, 2 cos x times the minus sine x and then doubled because expanding a squared bracket. Plus sine squared x at the end dx. And what we can remember is that sine 2x is 2 sine x cos x. So if I wanted 4, I would need to times it by 2. So times it by 2, and that's what I've got. So this can be replaced with a 2 sine 2x there. So let's go ahead and replace that, because that is then making this easier for us to integrate. Okay, and now really just doing it in each part individually. No, it's not so easy with the way you usually do it, is it? It's nice to change the... So we want to be using cos 2x as well. So that would be like a cos squared minus sine squared, which we haven't got. But that would be 2 cos squared x minus 1. And then there's a 1 minus 2 sine squared x. So looking at the first one here, if I want to rearrange this, is 2 cos squared x is equal to cos 2x plus 1. Obviously, I want 4 cos squared x, so doubling them up, I get 4 cos squared x is equal to 2 cos 2x plus 2. So 2 cos 2x plus 2. Then when I look at the sine, 2 sine squared x is equal to 1 minus cos 2x, and dividing by 2, a half minus a half cos 2x. So it's a half minus a half cos 2x. So let's put that nice and neat now. We've got 2 cos 2x minus, let's put the plus 2 minus 2 sine 2x plus the half minus a half cos 2x. Now we've got here 2 cos 2x minus a half cos 2x, so that's 3 over 2 cos 2x minus 2 sine 2x, and then I've got 2 plus a half, so plus 5 over 2 dx. So that's what we got. Now we can integrate nice and easy. So I've got my 3 over 2, and then we're looking at cos. So cos differentiates to negative sign. This is how I think about it. So it integrates to a positive sign. So we get a sine 2x, and then instead of when you differentiate, you multiply by this. So now we're going to divide by this. So dividing by 2, and that means that I'll have a 4 on the bottom there. minus, put the 2 there. Sine differentiates the cos, so it's going to be negative cos, so change the sign. And then divide by 2, so there you're going to go. Plus 5 over 2x plus c. So there we have it, 3/4 sine 2x plus cos 2x plus 5 over 2x plus c. I'm well aware that there are many ways to do this, at least 2 or 3, and you could change different points. I'm just showing you how I would go about solving it. Okay, and also depending on how you solved it, you'd have slightly different answers. So they'd be equivalent, but they wouldn't necessarily look the same. Okay, so question 9. That's what we got. Differentiate it. So y equals 3 plus 4e to the x squared to the power of half. So just changing the square root there to the power of half. So dy by dx is equal to a half. That'll stay the same. So that is 3 plus 4e to the x squared. And then I want to multiply by this differentiated. So this differentiated would be bringing this down. So if I was thinking of e to the x squared being my y and I differentiate it, I would be multiplying by this differentiated. So 2x e to the x squared. So this I'm going to be multiplying by, now because we've got times by 4, it's going to be 8x e to the x squared there. So that is what I'm going to be multiplying by. Obviously we've got the times half in the front, so that's 4x e to the x squared brackets 3 plus 4e to the x squared to the minus a half. Obviously you could put this back into a root there, on the bottom, but I'm going to leave it as is. It's only worth 2 marks, so let's not risk making any mistakes. Now, part B is quite confusing, but the equation of this tangent is y equals mx. It goes through the 0, so there's no constant. So just y equals mx. So if you think about it, mx is this. So that is 4x e to the x squared over 3 plus 4e to the x squared to the half. Okay, so that's the first one, and then that is times by x. mx. Now y is here, isn't it? So y is also 3 plus 4e to the x squared to the power of half. Okay. So now what we can do is we can multiply by this. So that would give me 3 plus 4e to the x squared, that would be to the power 1, equals 4. Now it's x times x is x squared, e to the x squared. Now we're pretty much there, aren't we? 4x squared e to the x squared minus 4e to the x squared minus 3 equals 0. And that is it. But it's realizing this is the equation of the line. And obviously the y value at this point is the same as this y value. Okay, so that is the key to part B. If you couldn't get part B, you'd still be able to go on into C and D and so on. Part C is pretty easy. Hens show that alpha lies between 1 and 2. So substitute 1 in. So we get 4 times 1 squared e to the 1 squared minus 4e to the 1 squared minus 3. And that equals, that equals minus 3, and then substitute in 2, so we get this. Now this one's not quite the same, so we've got 4 times 4, so it's 8. 8 e to the 4 minus 4 e to the 4 minus 3. And we get 215.4. So change of signs, therefore at least one root. Sorry, I just changed this value here. It's 652.2. I did 4 times 2. I did 8, didn't I? It should be 4 times 4, isn't it? 16. So 16 e to the 4 minus 4 e to the 4 minus 3. I set it out like that. A better way would have been, you know, to initially set it up like this. To say f of x equals 4x squared minus e to the x squared minus 4e to the x squared minus 3, and then you could have done your f of 1 equals and f of 2 equals. I just thought about that afterwards, just a little bit better in terms of setting it out. Now, part D, we are rearranging this equation to get this. Effectively finding our iteration formula. So we've got a square root, so we're looking at potentially an x squared. So here's our formula. We take this x squared out. So here I would have 4x squared e to the x squared equals 4e to the x squared minus 3. So it's like what I've done is I've just taken that over and that over. When I divide by 4e to the x squared, or I'll divide by e to the x squared first. So 4x squared equals 4 minus 3 e to the minus x squared. And then what I'm going to do is I'm going to square root, because we want that value on the outside, don't we? So I'll square root this. I suppose I could take it over, so I could take the 4 over actually. Doesn't really matter. So 4 minus 3e to the minus x squared over 2. And that's why I was going to square root first, just because some people might have separated these out. Sorry, not over 2, over 4. And then square root in, we get half square root 4 minus 3e to the minus x squared. Okay, alternatively, what I could have done is square rooted at this point, so I get 2x equals root 4 minus 3e to the minus x squared. And then divided by 2, so you get half 4 plus 3e to the minus x squared. Either way, that's right. And then it's just a matter of setting up your iteration formula. And once we've done it, you know, and you do it in your calculator, you get 1.129 to 4 decimal places, as it's asking for. And then x3, I just press equals 1.0997 for dp, and that is part 1. And then I need to keep going then to find what alpha actually is. So x4 is 1.1062. We've got x5 is 1.1048. We're getting in on it now. x6 is 1.1051. So x7 is 1.1051. You can see there, that's what we got. One. And then again, like if I did x8 just to show you, 1.1051. So that's what we've got there. So alpha is 1.1051 4 decimal places. So obviously we just needed the two in a row there to confirm alpha. If you can't remember how to set this up, it's quite easy. Go and check out a previous video on it, but I'll give you a very quick run through. You need to first put this value, x equals 1, into your calculator. So that is just put in, you do 1 equals, so it's 1 equals, and then it's in your calculator. Yeah, so then you can press afterwards AC. Then you're going to set up this formula. So you need to do a half root. Okay, so these are all in your calculator. You're setting this up 4 plus 3e to the minus. What's going on with my pen there? Answer squared. So that's what you set it up. So you put 1 in, so it becomes the previous answer. And then you set this up, so a half root 4 plus 3e to the minus answer squared. And then every time you hit that equals button, you will be getting the next value in the sequence, so each of these. Okay, final question. Right, fruit flies, blah, 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 blah. Find the number of fruit flies in the population at the start of the survey. So at the start, t is equal to 0, yeah, because time is 0. So that means that f equals 350 e to the power 0. So it's just going to be 1, 9 plus e to the power 0. So we've got 350 over 10, so 35. Now, given that there are 200 after 15 days, find k basically, or show k is that. So 200 flies after 15 days, so 350 e to the 15k over 9 plus e to the 15k. So that's what we've got. Let's multiply up. So 200 times 9, so that'll give us 1800 plus 200e to the 15k equals 350e to the 15k. So that means 1800 equals 150e to the 15k. So 1800 divided by 150 is 12. So e to the 15k. And then it's quite easy from here, isn't it? So this will be 15k equals ln 12. K equals 1 over 15 ln 12. And then we have part B. So first two parts of this question are relatively straightforward. Let's have a look at this third part. So for this one, it looks like we're going to have to differentiate. This rate is what we're looking at. So I'm just going to make a little bit of room. There we are, that's better. Right, now I need to differentiate this, so it's going to be quotient rule. Now notice I'm just leaving it in terms of k at the moment. We've worked out k, but writing this in constantly is going to get a bit annoying. So I'm going to leave it in terms of k, and then I'll stick this in later on. Okay, so this is going to be df by dt. So I'm going to differentiate 2, and it is v du by dx, and that would be 350 k e to the kt minus u dv by dx, so 350 EKT, multiplied by the bottom undifferentiated, which is just going to be k e to the kt, all over this bottom one squared. And now I just want to do a little bit of sorting out. So expand my brackets. We've got 3150, that's k e to the kt, plus 350 k e to the kt squared, minus 350 e to the kt, oh, there's a k in there, sorry. So 350 k e to the kt squared, all over 9 plus e to the kt all squared. So that is, well, these are going to cancel with each other. 3150 k e to the kt over 9 plus e kt squared. And of course this is my differentiation. Now what I need to do is put rate of 10 in when little t equals big T. I just want to correct some bits. That too, I probably should have kept it as the, this bracket squared, just in case you had a bit of confusion there. Okay, but it's the same thing. So when t equals t, df by dt equals 10. So this gives me, so that's where I'm going from here. 10 equals 3150 k e to the k capital T over 9 plus e k capital T squared. Now what I can do from here is certainly multiply up by this one and divide by the 10. Be nice. So that's going to give me 9 plus e to the kt squared equals 315 k e to the kt. Now bear with me, I'll just make a little bit of room. Okay, so I'm going to expand this bracket. So we got 81 plus 18 e to the kt plus e to the kt. This is obviously squared. We'll sort that out in a second. 315 k e to the kt. So what I've got is e to the 2kt. That's my e to the kt squared. And then I've got 18 of this minus 315. So 18 minus 315. So it's minus 297. Oh no, apologies, can't take them away because this one doesn't have a k and this one does. At least I spotted it then. So let's take e to the kt out and we'll have 18 minus 315k plus 81 equals 0. So here now we've got a quadratic. So if you want to, you could say let y equals this, and then it's kind of obvious, yeah? So this now we need to solve. So let's see, e to the kt equals, so it's minus b, so minus 18 minus 315k plus or minus square root of b squared minus 4 times a times c all over 2a. So 2 times 1. Okay, now what I would probably do is put k, which is this 1/15th ln 12, so 1 over 15 ln 12. I'll store this value as a. Okay, so it's just a reminder that k equals 1/15th ln 12. And then I'm going to put this into my calculator. So we've got, well, actually I could do 18 minus 315k, and that I will store my calculator there as b, as it is going to be a b. So I've got minus b plus square root of b squared minus 4 times 81, and that is all over 2. So my first answer here is 31.621. I'm going to store that as C. So I'll pop these in red here. Don't worry about them, that's for my reminder. Or e to the kt equals, and we've got minus b minus now. So what was it? Minus b minus square root b squared minus 4 times 81 over 2, and that is 2.5615. Now from here we need to work out the value of t. I'll store this one as d, so I can work on it. Now how am I going to do this? Well, kt, yeah, is equal to ln this, so this will be t, oh sorry, I had that in a red pen just then, so t equals ln 31.621 divided by the k, and that gives my first answer here as 20.8. Now my second one again is t equals 1 over k ln 2.5615. I'm using the full values there, so 1 over k, which is my alpha in this case, times ln d, and that is 5.7. And that is both answers. Quite a challenging question. I mean, A and B were really straightforward. A lot more work there with C. I would certainly suggest putting, the workings out of this, given what the question is saying. Okay, but I would then, you could, I suppose, could you use the function? You could probably use the function in the calculator to get your answers. I'll try it now and tell you. Yeah, you could use the calculator function because it does this formula to find these two values, but then you just have to work out these bottom two. Okay, if you couldn't think of how to rearrange it, bit precious from the exams, remember you could just take logs of both sides and rearrange it that way. You'd still get the same answers. So there we are, another video. Hopefully you get some use out of this, even if it's just one part of one question. Okay, but if you do get some use, please hit that like, and if you haven't already, please consider subscribing. Okay, cheers, see you next time.